Okay, if you've gotten this far, you've heard me more than once talk about uh, frognet memory, and that frognet memory is something that's available all the time, and that it's backed by a MySQL database, and that you access it using the tuple space, right? And the tuple space is a concept that was produced by Galentner back in 1985. And it describes a way to access memory based on what amounts to a three-dimensional key. So you say that any piece of memory can be accessed if you give it three keys, and those keys can be anything you want. So if you have a database that is global, this is it. You can think of it as being the same as a backplane memory on a parallel computer, and you have a way to address that backplane memory. Then you can get at it from multiple programs that are running on that same machine, or since we're changing the programming surface, you can get at it from multiple programs that are running on our network. And doing that uh, is a convenient and easy way to address global memory, because it gives you a way to make it unique without having a huge possibility of conflict and overlap. So when I first got to the concept of the shared memory, I wasn't thinking of it as shared memory. I was thinking of it as a place to store sensor data. And because these little pies are just built for sensor platforms, right? You can go out and get pH meters for them, temperature, motion, all kinds of stuff. And what I wanted to do was be able to put that online and make it available across my network as quickly as possible, so it can be consumed by dashboards and by AIs and everything like that. And that's when I came up with the concept of using tuple space and what I called at the time a transient database, and that gave me what I needed for sensors. And I stored the sensors using a scheme that called for three elements: the sensor name, the sensor type, and the sensor location, as you can see here. So this is actually the transient database. Every frognet runs this, every single one, because this is both the local database where you're storing your templates and your caches, and potentially the transient database for your network, should you happen to have the highest IP, or be the one designated through the qualification system. So every single frognet has one of these, and you can do a show tables. These are the tables that are in here. Now, some of these tables, I'm going to admit, I put this together a long time ago, and it wasn't until I really started getting an understanding of what frognet shared memory was that I realized that some of these can probably go away. Others, maybe we really want to show up. This is one of those areas that we can really, expand and look around in, because I can demonstrate the usefulness of the Galantner tuple space. That I can make very obvious through the communicator and through the Frognet monitor, things like that. But having an actual database, even if it's one record only, right, and having tables defined in that database, even if it's one record only, that's some interesting possibilities, right? Some things you could do with that are just like gnawing at the back of my head, going, this is kind of cool, and I want to see what people can do with it. So what we've got in here, if we look at these tables, let's see, the HTTP response cache, that's needed. Known frognets, you need that. The semcache, all these semcache needs, all these semcache ones are here. Sensor and sensor data, those are the big ones. And then many of these team member, uh, user, the transit peer cache you need. These were all ones that I had thought of in terms of building teams or communities or something like that. So those haven't really been explored, but they're still here. Something we need to do to get this all back into fighting shape. Um, the ones that are important, like I said, are sensor and sensor data. And if you look at sensor, that's the one we had up when we first came to this page. Uh, describe sensor. Oh, come on. Oh, it is a capital S. So this is actually the tuple space table. So sensor, and it's actually two tables. There's sensor and sensor data. Sensor is used to set up the metadata for the data. And so the three tuples are identified here as sensor name, sensor type, and sensor location. Those can be anything you want. Those are the ones that you can think of as just A, B, and C. So if you were a pair of programs, let's say you were writing a program that you want to work across the network, you might have for the first tuple, you might have the program name. For the second tuple, you might have the variable name, and then for the third tuple, you might have the something like the variable location, right, or the user ID or something like that. But it would be a way that you would get to the unique data for that tuple, and being able to read it and store it is what you do in this table. The actual data goes into sensor data, right? And sensor data just has the sensor ID and the frog ID. The sensor ID is the primary key for the sensor table. The frog ID is a unique ID assigned to your frognet. Uh, and then there's the JSON data, and then there is updated at, which is the envelope information. The JSON data is the important thing. It's a long text, so you can put in pretty much anything you want. So if we do a quick select star from sensor data, it's not going to make a whole lot of sense because of the way keys work, but we can look at it and see this is some sort of a status video, some sort of a status thing. And is there are a couple hundred of these things, and what they do is define the system, right? So a lot of these look alike. That's kind of indicating to me that maybe I've got some kind of a leak that I need to look into. But here's another one. This is, this is a system information. The architecture is Arch 64, port 9000, 4 cores, stuff like that. So this is all just defining what a machine looks like, right? And this is just the sensor data. That's all it is. And so you can put the sensor data in. It can be soft generated. It can be hard generated. It don't matter. You enter it into the system. By the way, the database name is Frognet. So you just do MySQL Frognet and you're in, as long as you're root. You put data into the database with metric upsert. Usually, that's what I like to use. And so you give metric upsert and you tell it the sensor type and this metric name. So, really it's A and B and then your JSON data, and it makes C your location, your IP address. So that's how we get metrics in there. What it does in here, you will see, uh, it uses a thing called API.php. Where is it? There it is. Okay. So I'm not sure where it is exactly. Oh, here it is, API path. So API.php. And if we then look at API.php, that's in var www html API.php. At the top of this file is are the table definitions, and this should reflect the schema that is currently running in the database. And then there's all these other things to read and set and, fetch all, right? Here's fetch all. There's also, fetch single, and there's create, update, all that stuff. So this is a full up CRUD, and everything that's in here is actually tested and works. And you will see that this is doing database upserts to the local JSON, to the local database, right? So when you call database host slash API.php, no matter what machine you're on, you're going to get this file, and it is going to impact the local version of the MySQL database. And as we are going to assume that that is currently the database host.frognet, which makes this frognet memory. Straightforward, huh? The whole thing kind of comes together, like I said, for writing when you're looking at metric upsert, but for reading, the better example is user local bin, frognet monitor, py. And there are 3 versions of the frognet monitor out there. They're not all alike. One is a C++ version, and one is a Python version, and one is a C# version. There's also the JavaScript version that you saw the other day when we did the I think it was discovery, and I showed you the route map. That's another version of something that just looks uh, into global memory. We're not sending messages around for all this stuff. What we've done is API.php and its related functions are the compiler, right? It is how we go from conceptually, how we go from assembly language to C, because we move from having to deal with, moving registers. What do all those REST things do? They move data. They just move data from one side to another. And you need, you have on a game, for example, I did game servers, some of the first internet multiplayer game servers for Sierra Online, and then I followed it up with Electronic Arts and then Wizards of the Coast. And in game services, you would have, a game service that, you know, users would have to log into. Let's just take a simple game like backgammon. So you have a system that is the centralized server, that is you know the authoritative server for backgammon, for your backgammon game, and you have a client, right? So somebody decides they want to start a backgammon game, you have to spin up a copy of that server for them, or you have to make some other accommodation. I'm just saying this is one way you do it. Uh, but you spin up a server for them, let them occupy the number one slot. You send them back some messages that say, okay, you're in this game and you're in this slot. And you don't have any opponents yet. And, all the other information you got to send back to them. And then they sit there and they wait and they poll. And at some point in the future, somebody else joins and they become player number two. Now you have to send that whole bunch of information back down to player number one, bunch more information back down to player number two. You're not going to allow them to talk to each other directly. That doesn't happen because you're not allowed to make a socket down, right? The firewalls get in the way. You can only make sockets up. So you're going to the server, and you're just exchanging a ton of information back and forth about each other, so that you can synchronize with each other, get your conditions right, and then you can launch the game. And then once you launch the game, you have a whole bunch more stuff that you have to do. Is the board right? Are you moving your pips in the right direction? Are what are the rules that are applied? Did somebody cheat? All that kind of stuff. And it doesn't have to be anymore. You can instead have memory that says, this is game number 247, and player one is Bob, and Bob doesn't have an opponent yet, so this is an open table. If you want to come in, you don't have to do anything except write to the memory that says you are player two, and you become player two. And then Bob, he checks and he says, oh, hey, I have a player two. Great. I'm going to go read its tuple that tells me about him. Great. That's it. You just say, read the tuple, and you get back everything you need to know. You say, read the tuple for the game. You read that. No more sending messages around, no more assembly language stuff that we have to do. Sending messages is the assembly language of distributed programming. And it's time for us to move up to C at least, and C++, right? We can write libraries that are this kind of system. And when I think about we can do uh, a lot of the automation that I did on a regular basis can become a library, and and be distributed on an as needed basis. But you're affecting memory. REST is still there. Okay, I'm still using REST. I never stopped. Just like a C compiler generates assembly, we're still using REST underneath the covers because we still are updating, an endpoint. We're going through to Apache, but you don't have to think of it that way anymore. That's the big change. That's the thing I want you to get through, is you don't have to think of it as REST anymore. It is now memory, and you can access the memory, and you can work with the memory, and you can set the memory. And that's what we look at when we're in uh, the monitor. And so this is the end of this video. The next video I'm going to do, we're going to take a look at what's in the various monitors, the three monitors, and get an idea for how we're going to use this endpoint, this new API going forward to enable so much more. So hope this was useful, and we'll see you on the other side. Bye.